much it. So given that we've got the initial position of our projectile, we can turn the pointing vector here into a velocity vector and then use set linear velocity, and I can't fit it all on the screen there, set linear velocity to make that object move in the direction that we want at the velocity that we want, or in the magnitude that we want. All right, so I can see that you guys maybe, hopefully this is clarifying things a little bit for people. Why don't we take a look at some of the code? So if you were watching last week, or if you've watched prior episodes, you will be familiar with level files. So our level files are merely a table containing 3 subtables, one for platforms, one for dangers, and one for other, where we use tokens to specify the virtual position of things. And I'm not going to go through it because we did this in a prior episode, but all of this gets sucked into game, a script in game Lua, and then another script in level loader, and it gets manipulated, massaged, examined, and converted into a table, a bigger table of subtables that can be used to build things. And in each case, when we build something, we call a function in one of the modules: round, square, laser turret, horizontal path, etc. And just find it here. I've got I just upgraded to Windows 10, so everything looks a little bit different. If you look under the scripts builders folder, you're going to find a whole bunch of scripts, and each one of these scripts is a module used to build one world object. For example, round is used to build these guys right here, whereas rocket turret is used to build this guy right here, the one that's firing the rocket that I've paused. So today we're going to talk about some of the turrets, and we're going to start off on the simplest one, which is the laser turret. So I say simplest, but actually this stuff, when you're first doing it and you're new to the math, it's kind of like, it's very complicated. So this is the point where I was going to say, Sergey made announcements about his plugins. I have decided to start propagating SSK content, some of it as plugins. So I'm currently working on 3 plugins. One of them is the math library. I'm gonna extract the SSK math library, which we're using in this example, as a plugin. The collision calculator, which is my cheater for calculating the collision filters, is getting released as a plugin. And a library that I call the action library, which we may not have time to appreciate in its fullness here, but basically it takes the aiming that is going on here and the steering and the thrusting in the forward direction that makes it possible to make this missile. All of that taken down to 3 lines of code. So the action library is basically a super library, which isn't very long actually, but it's some fairly tight code that handles very fundamental action movements like aiming, thrusting, steering, stuff like that. Seeking targets, all kinds of stuff like that. It comes in the library, which will be a plugin released hopefully sometime in the next couple of weeks, once I get my act together on the documentation. Now I don't know about you, Sergey, and you don't need to answer, but you can just nod your head. I think the hardest part isn't writing a code; it's writing the documentation. I don't know. Maybe Sergey's good.
I have one thing to answer to that. You don't need to write documentation if you expose only a couple or one method of the library.
Unfortunately, I can't do that. That would be nice. So if you've been following along, I'm going to get back here to the file. The laser turrets are similar to all the other builder files. At the top, they require the common settings, They also now require utilities. One thing that I'm going to start doing here is I'm going to go back through this code. We've gotten to the point now where we've got 13 builders, and these builders are doing a lot of stuff that is similar. I'm not a big fan of having code that does the same thing in multiple places in my games. So wherever I find common actions, common code that can be easily moved, it will go into the utilities module, which then will allow me to do stuff like all of the junk that you see written here in several lines of code, or like this one, this really long one for drawing rocket trails, and use it over and over simply by calling a single function. So what I'm saying here is instead of including 100 lines of code to draw trails every time, for every time I do a rocket, I'll just have a module, builders, utilities, that is. I will require it here at the top, and then I'll call the functions in it that I need to draw the rocket trails. Okay, so another thing that you may not be familiar with, unless you looked at the player builder, is I'm doing a little localization. So as I just mentioned, I've got a math library that comes with SSK, and SSK will continue to contain it because I use SSK myself. But one thing I always do is I localize the math functions I'm going to use. So these are all 2D math functions. For example, this one scales vectors, this one subtracts vectors, normalizing a vector. Normalizing a vector, by the way, is how you take a regular vector of some length and convert it to a unit length vector, a vector of length 1. So I won't show you the math, like I said, because it's sort of complicated. I'd probably stumble on the explanation. Another couple of functions I use all the time is converting a vector into an angle and converting an angle into a vector. Oh, and I forgot to mention that. This is important. Sergey and I think we're in different schools on this, but it doesn't really matter what school you are in on this as long as when you do it in your games you're consistent. For me, this is 0 degrees. This is 90 degrees. This is 180. And this is 270. Now, some people prefer did I mess something up? Yeah, no, I didn't. So some people prefer this, but for me, it's just always been simpler to think of up in the game world as being 0.
Wrong.
Go ahead.
You got the second one wrong. It's 90 at the top.
Oh, some people do this then. Oh yeah, you're right. Via normal Cartesian. This always messes me up though. So this was.
Is that counterclockwise? Oh, okay. Zeros.
Is this 180 or is this 0? I can't remember that.
This is 0 to the right.
Yeah. That's Cartesian. It's flipped. That's another thing where people get really confused is because when you're working on Cartesians, the coordinate, the rotation of these vectors, the angle changes, and the reason it does is because of the direction of the y, minus y versus plus y. So.
In my games, I always imagine 90 being at the top regardless of the y-axis.
Yeah, it doesn't make sense to me personally to put 90 at the top because I don't think of a 90 as forward or up. I think of 0 as like up. I don't know. Okay, so the reason I think this way, just as interesting discussion, is when I draw a picture of a guy smiling, he's up. He's facing up, right? So if I were to rotate him like this, then he'd be facing to the right. If I were to rotate him like this, he'd be facing to the left. And so for me, it's easier to think of up as 0 degrees instead of 90, because once I make it 90, and then if I rotate to the right, that's what? 180 degrees? It just starts to feel really weird to me.
For me, I imagine a plane, for example, or a car top-down that writes from left to right, and that's very similar movement, very common movement in video games, and that's usually 0 degrees.
Well, that's an interesting point. I mean, I totally, I'm not, I understand what you're saying and where you're coming from.
Yeah, because in that case, the car would be up in that it would be pointing in the 90 degree direction, right? The
Right.
top of the front of it might be pointing towards 0, and then the top of the car would be pointing towards 90. What is that? Is that a pickle?
That's my poor man's airplane.
Oh, okay.
18 plus.
I'm not flying on
Long
air.
story short here, folks, those of you who are listening, we're in the ED coordinate system where this is 0 degrees, this is 180 degrees.
It's space.
Yeah, it's not a big deal. Just
No, it's not.
some assumptions.
It's not. It's just that you have to realize as I speak that these are the things that I'm saying. This is